Hi, statistics students. Today our goal is that you can construct a Venn diagram from data and answer probability questions with it. Let's get going. We have a table here talking about the genders male and female, and if there's piercings or no piercings involved with the genders. Okay, it's the first thing it says construct a Venn diagram that displays the same information using P equals pierced ears and F equaling female. Okay, so what do I mean by that? What is a Venn diagram? A Venn diagram is two circles, okay, that kind of intertwine, I guess, per se. And what I'm going to do here is I'm going to put a P. Sorry, my computer's running a little slow. Come on. Here's P for piercing. Here's F for female. Okay. Now, when you are doing a Venn diagram, the first place that you always want to start is again, I'm waiting, forgive me. Patience, right? The first place you always want to start is you want to start in the middle. Okay. So let's start in the middle right here and let's look. Let's see. We want to know in this middle right here, this is going to be how many people said that they were female and also had a piercing, okay? Because we have piercing and female. So this center represents all the people who, like if you're filling out check the box thing or whatever, you say, I'm a female, I have a piercing, okay? So there were 84 people that were female, right? And also said they had a piercing right here. Next, what we can do is we can fill out these sides here, okay? So we can look here and say, okay, well, these people right here, they are saying that they are females, but they don't have a piercing because in black is where they did have a piercing. So in red is where they don't have a piercing, but they are still identifying as a female, okay? So that is identifying as a female, right? With no piercing. That's right here at 4. So I'm going to put 4 right here. Okay. Next over here, these are people who identified as having a piercing, but not as a female. Okay. Not as a female. So that would be the males here, identified as having a piercing and being a male. That's 19. So if I look here, 19 plus 84, that's everyone here who said, yes, they have a piercing, okay? Everyone who has a piercing. So that's 103 people total, okay? Next here, if you look here, we have the 84 plus the 4. That's everyone right here, a female, okay? So that's what, 88 together. But we're missing something. We filled in the 19, we filled in the 84, we filled in the 4, but we missed out here. Let's see, what color have I not used? This one right here. These are people who do not identify as having a piercing, do not identify as being female. It's the people who identified as males with no piercing. 71, that goes out here. Okay, and so what I can do is I can add these together to 75, right? 103 plus 75 gives me 178 as a grand total. And then what will happen is you'll be asked probability questions off this. So what's the probability if everyone was in a hat, right? So all, 178 people's names were in a hat. What's the probability that I would select a female who had no pierced ears, okay? So female with no pierced ears, we can identify that from the Venn diagram or from the table, but there are a total of 178. So the females who did not have pierced ears, here's everyone who identified as a female. These people here, they identified as being female and having a pierced ears. This 4 right here, they identified as being female with no pierced ears. So there's my probability right there. Find the probability of randomly selecting a male or a pierced ears person. Okay, now we see this or right here, guys. So that means we do need to use that addition rule. So we're going to say the probability Again, patience here. Sorry about that. It's taking a second. The probability of being male. Oh, okay. I might have to just write it out. My computer's really slow right now. The probability of being male plus now the probability of having pierced ears. So plus the probability of P minus the probability of both being male and having pierced ears. Okay, so we want to look at this and we want to say, well, how many, or what's the probability of being male? Okay, so the probability of being male, I think it's going to be easier personally to read this two-way table here. So 71 plus 19, that's going to give us 90. Yeah. So again, I'm using that addition rule, and this time I'm using the two-way table. So all of the males, the probability of being male, there are, I think what I say, 90 out of 178. Then there are people who have pierced ears out of 178. So let's see how many people have pierced ears. There's 103 people who have pierced ears out of 178. And I talked about this in this last video. This means intersection, that's the same as and. So out of the 178 people, how many are male and, ooh, baby, and also have pierced ears? Male and also have pierced ears, there are 19 right here of those. I'm going to use my calculator this time to calculate this. I'm going to add those numerators together and subtract. So 90 plus 103. Oops, I don't think I got 103 in there. Oh, I did. Oh, I got 9 though. 90 plus 103. Hit enter, minus 19, and I get 174 out of 178. Okay, let's move on to the next example. In a large apartment complex, 35% of residents read the USA Today, only 20% read the New York Times, and 5% read both, okay? So it says constructive Venn diagram to represent the setting. So I'm going to do two nice big circles. I have the USA Today, and then I have the New York Times. So now I want you to look at something. I want you to know that this is different because now it's percentages and not counts, okay? Again, now how this is going to change is just a little bit, so hang in there with me here. First thing I want to do is I still want to start in the center, okay? The center is going to represent, remember, people who read the USA Today and also the New York Times. That's 5%, okay? So I'm going to put 0.05 for 5%. You can get that by moving the decimal 2 to the left or dividing by 100, okay? Now, here's the next part. Let's fill in everyone who has the USA Today. Now, here's where people start to make errors. The percentage of people who read the USA Today, that's 0.35. So this whole circle has to represent 35%, right? Because the people who read USA Today is 0.35. But I already have 5% in this whole circle. There are people who read the USA Today that don't read both. So what I need to do is I need to take 35 minus 5 to give me 30. Now this whole blue circle has a 30 with it and a 5 with it, which gives me 35%. These people read the USA Today, but they do not read the New York Times. Okay. Next, let's talk about the New York Times. And the New York Times, we know that there is a total of 20% of people who read the New York Times. That means this whole purple circle now that I just redrew has to equal 20%, already 5% inside of it. So I'm going to do 20 minus 5, which gives me 15. And this represents the people who Times, but they don't read the USA Today. So what did I do with step 2? What I did with step 2 is I used subtraction minus, I put for subtraction, to fill out the other parts of the circle. But finally, there's one thing I'm missing. There are people who don't read the New York Times and also don't read the USA Today. That's the people out here. Well, that had this, okay, so just like over here, I should have talked about this and I didn't. Usually what we do is we put a rectangle around the Venn diagram now, because this represents the sample space, everything that could happen, all the different possibilities. The same thing has to happen here, guys. If I made, oh baby, a rectangle here, this has to represent all the possibilities and it has to add up to 100%, okay? Or the total counts like in the previous problem. So if I take 30 plus 5, that's 35. 35 plus 15, that's gonna give us 50, right? If I put a 35 there and do that math, 10, carry the 1, yeah, that's gonna give us 50. So 50% is on the inside. This whole thing has to add up to 100%. So I'm gonna do 100 minus whatever was left over, okay? Or I'm sorry, whatever is added up for the circles. So we're gonna add up the circles, right? Do that. So 100 minus whatever that sum was. So ours was 50. So 100 minus 50 is 50%. So I'm gonna put 0.50 here. All right, let's answer these questions. Find the probability of reading the New York Times, but not the USA Today. Well, that's on the Venn diagram here. Here in purple is the probability of people who are reading the New York Times, but not reading the USA Today. Okay. Find the probability of not reading the USA Today, okay? Well, not reading the USA Today, sorry, spoiler alert there. Where do I not read the USA Today? I don't read the USA Today here, but I also don't read the USA Today here. So I need to add those two together, 0.15 plus 0.50, and that gives me 0.65, okay? All right, last, and that's it for this now, okay? So again, just to quick sum this up, right? We do our circles, we do the center, then what we do is we say, well, what does this whole circle equal? It tells us in the problem. We do subtraction from that middle to figure out that outside. Same over here. And then, so we use subtraction to fill out the other parts. And then finally, what we need to do is we need to add up the sum, so everything in the circles, and subtract from 100, okay? And that's where we got that 50% out there. All right, last thing, what I want to do is just a quick summary of the Venn diagrams. So if I have, you know, A and B here, okay? What part is A and B? Well, A and B, if I would shade that, that's going to be what's ever in the center. Okay, so that's A and B is that center part. Okay, now if I have that Venn diagram, A but not B, so here's A, here's B, here's A and B. I want A but not B. So that's out here. Okay, A or B, some people get like mixed up on this one. A lot of times what people say is they say A or B, but here's the issue. If I said to you guys as a class, I said, how many of you own a dog or a cat? You'll raise your hand if you own a dog or a cat. But then there are gonna be some of you who raise your hand that actually have both too. So when we say A or B, that does include both. Some of you do own both, okay? That one's this is the one that people get wrong mostly, okay? And then here we have B, but not A. So here's A and B right here in the center. Here's B, but not A. And then not A and not B. I think I meant to put not B as well. That's out here. Okay, so if I have my rectangle, not A and not B is everything out here. All right, ladies and gentlemen, that was reviewing the addition rule and learning about Venn diagrams. Have a great day.